All righty. Good morning. Wasn't that a fantastic keynote? I really enjoyed that. It really, really great way to think about stewardship versus ownership. It's really great to be at Longhorn this year. I have not been since before 2020. I don't remember what year it was. So it's been a little while. It's great to be here in person. I'm really happy to be able to hopefully relay some information to you to help you with your stewardship, to continue the theme. And I'm also hoping to learn a few things this year as well. And I think that's why we're all here, is that we want to be better software engineers. We want to be better at what we do. That is a goal of mine, is to better our craft, to better my craft and what I do. I hope that's your goal as well. Because if we're not trying to be better engineers, I don't know about you, but if I'm not trying to be a better engineer, I start to feel like I'm coasting. I start to ask myself, why am I doing what I'm doing? Why am I here? Isn't there something I could be doing better, right? So this presentation has been developed and born out of the last 20 years of my development experience and trying to understand, trying to write understandable and easy to maintain software. So let's go ahead and dive in to that. Now, as we start down this path of thinking about namespaces and how to organize our code, I want to talk about code comments, which might seem a little bit odd to you, but I think if you stick with me, you'll start to understand where I'm going. Now, as we start talking about code comments, we could derail, and we could talk about how you should comment the why of something and not the how of what you're doing, and how you shouldn't clutter up your code with useless and needless comments. We could dive into code comment philosophy and talk about keeping your code comments fun and casual, but brief and to the point. But I don't want to talk about any of that, though, as you can tell, I have opinions about it. I want to talk about where code comments belong and why they belong there. So where do you put code comments? Where do they go? This is not a trick question, but it's something you probably haven't really considered. It just seems intuitive to you of where to put code comments. Because you wouldn't put code comments in a giant documentation file, right? You don't have a big file that contains all your code comments that's separate from the code that you're writing. You wouldn't put code comments in a directory structure that mirrors the structure of the files and the classes that you're working on. Where you have a path that exactly matches the class that you're working on. You wouldn't do that. And you certainly wouldn't put your code comments in the company wiki or on Confluence or in Jira. Like, that doesn't make any sense, right? I hope those things sound really silly to you. They're supposed to sound silly. That's not where you put code comments. But have you really thought about why we put code comments where they are? Code comments are best and most helpful when they are co-located in line with the code that is being commented upon. And because it's so intuitive, you might not have thought about the reasons why we do that. Could you name the reasons why we do that? I would say it's because the code comments are easy to use while updating and writing code. They're right there with the code. It's right with the code. You can't miss it. And if the comments weren't right there with the code, how would you know they existed? Where would you go to find them? And if they were somewhere else, you'd have to maintain this mental model of where the code comments are, what code comments might be relevant to the code that you're working on at this time. And you're adding a mental overhead and a mental tax if you store your code comments somewhere separate from where your code is at. So even if you know those code comments exist somewhere, how would you go about finding them and updating them and maintaining them over time? Code comments in line with the code make things simple and easy to use and easy to maintain. So where am I going with this? Well, I hope that's obvious. I hope that given the title of this presentation, the co-location of related things together, that you can start to see that the springboard from code comments becomes easy to see where we're going. But I think first we have to talk about the more common convention in how code is organized in PHP. So let's talk about that for a minute. I would say that by far, the most common code organization convention, the most common namespacing convention for your code, is to organize by technical concern. And these are, you have a namespace for your controllers, a namespace for your services, a namespace for your models, et cetera, et cetera. You kind of get the idea. That's organizing by technical concern. And certainly, this has been the case. Any code base I have ever inherited has been organized in this way. I have never inherited a code base that was organized in a different way than by their technical concern. It's the most common convention for organizing code. And if you take a look at the PHP projects over, say, the last 15 years, this is the way developers have tended to organize their code. They've tended to organize by technical concern. Why is that? I think it's because it's the closest analog that we can come to for organization that is very quickly apparent to us. Because we may not yet understand the business needs or the needs of the application in general, but we know things like controllers and services and models. And so we organize our code that way. And this is even, I would say, even more particularly true when we know less and we know less about the system design and maintenance because maybe we're less experienced engineers. So we start off organizing that way, and we've never really questioned it over time. But we certainly know about language features and about the things that we think are separated by their technical nature. And so often projects will be organized like this. They'll be organized with a namespace for controllers, a namespace for models, and a namespace for services, whatever those are, right? And a namespace for views, again, whatever those are. In Laravel, let's say, they tend to be templates. But you wind up with your feature or your service or the thing that you're working on spread all over the different namespaces of the application. And it becomes really difficult and hard to reason about as your application grows. And then the dividing line between model and service and controller can all get pretty vague. Now, I love to draw boundaries around vagaries, but in order to do that, I think we have to stop and step back and understand that I think the conceptual model of organizing by technical concern is a fundamentally flawed model. It pushes us in directions that make our code harder to understand, more prone to bugs, hard to change over time, which is a big concern, especially as you work on applications that are long-running. Changing over time, it's a big problem. And it makes things hard to take care of, it's hard to back out of that way of thinking, because when you go to add a new feature or a new class or whatever, you already see the organizing principle, and so you add code where you think it goes. So it gets hard to back out of. And this way of thinking encourages us to cross the boundaries that we have drawn with these namespaces to get what we want all the time. Because the boundaries that we're drawing by these technical concerns are pretty meaningless when you stop to think about it, architecturally speaking. And I'd wager, in fact, that you don't think about the organization of your code as drawing boundaries at all. You just think, if you're working in your controller, you say, well, I need these three services to get the job done that I want. And so you cross the namespace boundary into the services namespace to get those things. And you've crossed these artificial boundaries without batting an eye. And we've trained ourselves by organizing by technical concern that these boundaries are meaningless and that we don't even think of them as boundaries. Now, as we start talking about boundaries and namespaces in that way, I don't want to say that you should never cross boundaries, right? Otherwise, you're setting up a bunch of silos in your application and they can't talk to each other or the outside world. That's not what I'm suggesting. But I would suggest that the boundaries we've traditionally drawn in the PHP world are so meaningless that they serve to teach us the wrong lessons and make us focus on unimportant trivialities when organizing our namespaces. And then when we organize our code this way along these technical lines, we have an application that is well organized, but it's still a bit of a mess, right? It's well organized along its technical lines, but it's not organized in a way that helps us to maintain it over time. It's a big, messy ball of mud that really does become difficult to work on, right? As it grows, you have the different disparate parts of your feature, they're scattered all over. So boundaries along technical lines, I would argue, reduces comprehensibility. Organizing by technical concern, this analogy that I came up with is if you were to organize a library by book color, okay? So if you went into a library, you wouldn't say, where are the red books? Well, they're over here, and the blue books are over there, and the gray books are up on the upper level. That's not a helpful organizing principle. You never want to know the color of a book. I've never wanted to know the color of a book when I went into a library looking for a book. Neither would organizing books by their size be helpful. The 4x8 books are in this section and the 6x9 books are over there. Those are technical aspects of the book that really don't matter to me when I'm going to a library to look for a book. I may want to know things like author and genre or subject or title. Those are helpful organizing principles, but book color and book size really aren't that helpful or useful when you're looking for a book and the knowledge that you want from the book. So as a young software engineer coming up through the ranks, I would wager most of you started hearing how you should organize your code by putting your controllers in a certain namespace and your services in a certain namespace. And as I am prone to do, I became religiously opinionated about how you should organize your code. And if you weren't organizing your code that way, that was bad. You know, your controllers belong in a certain place. That's just how it is. Your services belong in a certain place. But of course, I didn't stay a young, unseasoned software engineer, and I started working on bigger and larger projects, my own and others that were given to me to work on. And I found it became more and more difficult to work on isolated system features because they were scattered all over those namespaces, and this mental model wasn't really helping me understand how the application was actually functioning. And so I started asking the question, why are we organizing our code along technical lines? Why do we do that? How does that help us in its long-term maintenance and stability of the application? And I couldn't come up with good answers to those questions. It's a difficult place to be in when a lot of the people that you look up to and respect, the pillars of the community, the software that you use, all think about things in a certain way, and you're asking the question, why are we doing that? It wasn't a comfortable place to be in. And so I started looking outside the PHP community for answers. Now, as I've started doing this, I've realized there are people in the PHP community who were asking these questions as well, or who had already come to better solutions. So these thoughts are not original with me. But at the time, I didn't know that, and I was trying to figure out what is a better solution that we can come to for helping us to understand and maintain our applications. And so I couldn't come up with good answers to those questions, and as I said, I started looking around. So what are we going to do instead if we're not organizing by technical concern? How can we organize our code and our namespacing and our boundaries that produce higher quality code? How can we organize things in a way that produces better comprehensibility and long-term stability? So as I looked around at non-PHP solutions, I came across this quote by Richard Gabriel. He's a Lisp. He works in Lisp primarily, or he did. I think he's retired now. And I thought this was a great quote to really start to think about how we can organize our code instead. The primary feature for easy maintenance is locality. Locality is that characteristic of source code that enables a programmer to understand that source by looking at only a small portion of it. The primary feature for easy maintenance is locality. So what I'm proposing, and again, these ideas are not original with me, I just like to popularize them, is that instead of organizing along technical lines, that we should instead be thinking about the use case and organizing our code by use case. Now let me step back and define that a little bit. Now, as we think about use cases, this is going to allow for that locality that Richard Gabriel described. And we're going to use logical, well-defined boundaries for our use cases. Use cases are all about how users interact with a system. Use cases allow the system to be broken into logical components. Use cases are designed around features and system capabilities. And this is from the standpoint of the end user of the system. And I do want to point out, the end user doesn't have to be just a human, although often it is. The end user can be a human on a computer or a mobile device, but an end user can also be a machine, a cron job, a scheduled job, or what have you, or a feature may contain both targets for a human using the software and a machine using the software. So use cases can be defined in multiple ways, but it's a far better way to think about how to organize our code and how to draw good boundaries. And so we want to be better software engineers, and I would argue that organizing by use case really helps us to do that, or you can think of it as the business case of the application. and not by technical concern. Thinking very carefully about boundaries will help us to level up and become better software engineers. And technical concerns, when we start thinking about how systems work, become unhelpful boundaries. This is something I had to, when I was a mid-level engineer, I really wanted to advance and become a more senior engineer, and I started realizing that this was the way forward because I was being held back by thinking about my app as a collection of technical concerns, my applications as technical concerns, and I should be thinking about them as the features and the use cases that they provide. And that's how we level up. That's how we learn how to draw, is by drawing good boundaries is how we level up. And I started out by drawing unhelpful boundaries around technical concerns because I could easily understand the distinctions of those technical concerns and my inexperience with how systems work and what's needed to make them work. And so to grow as an engineer, I had to break out of that thinking in order to draw better boundaries around the features of my software. And I had to start thinking more deeply about how the application actually works. You have to understand what your app is actually doing and what it provides so that you can draw helpful boundaries. And organizing along technical lines are unhelpful boundaries, and it doesn't help us with the mental model of how our code is actually flowing through the system and what it does. So bear with me a minute. I know that this is a PHP conference, but this code on the screen might scare you because it doesn't look like PHP. It is, in fact, React. And I know that can be scary for us PHP developers. We don't like the front end sometimes. But I've been writing a lot of React for about the last year. I really sort of avoided React. I didn't want to use React. And my boss at the time drugged me into it, kicking and screaming. He's smiling at me. He's back there. He's no longer my boss. But he started us down this road of using React. Because on my team, we're all full stack developers, so we do have to write front-end code and back-end code. We have to do both. And for a long time, I would use jQuery or vanilla JavaScript to get the things done on the front end that I needed. But then I got drugged kicking and screaming into React, and I have found that React has revealed some patterns that I think may be relevant to us as PHP engineers. And one of those things is, it turns out that keeping related things as close together as possible reduces complexity and decreases mental overhead. And with modern JavaScript frameworks, I know the most about React, but I know Vue has some similar things. A byproduct has been that related things are kept together in one place in the front end. Now let me back up even further and talk about Tailwind. Who here uses Tailwind? Nice, okay, a few of you. I had already started down this road of thinking about a better way to organize our namespaces in PHP when I got my first sort of look at Tailwind. And like probably most of you, I balked at it because it just looked like a mess. You've got all these classes in your HTML. It just looked like garbage. Look at them, and isn't this just like inline classes or inline CSS when you start to think about it and you realize, well, it's utility-based CSS. You have one CSS declaration essentially, and you're just making them classes. And so it feels a lot like inline CSS, and we're taught that that's bad. Don't put your CSS in line. And I certainly felt that way when I started using Tailwind. But then I sort of had a eureka moment about Tailwind, and as I was forced to use it and then got to a point where I wanted to use it, and it became apparent to me that what Tailwind provides was a way to keep all the related bits of that front-end component that I was working on together in one place. And there was a lot less mental overhead where I didn't have to keep track of the CSS declarations in some other place that were relevant to the component on the front end that I was working on. And so I finally got it, and I had that eureka moment. I was not hunting down CSS anymore. It's right with the component. There was no worrying about whether I should or should not delete CSS, because Tailwind takes care of that for me. If it scans your templates and finds that no CSS is used, it won't output the styling, the CSS for those classes. Everything in the component is right there where I need it at any given time. You can understand the component because it's all together. And then, of course, I started using React and Tailwind together, and this was another revelation to me. Everything now, not just the styling and the structure, but the behavior of the component is now all controlled in one place in React. And everything became a lot simpler to work on the front end. Everything related to what I was working on is in one place, and with React, it's by convention, it's not by necessity, so you can still have like a folder full of components that you pull in over in some other part of your React application, but That's not what you're encouraged to do in the React ecosystem, and certainly not the way we've been working on my team. We have been putting everything related together in one place in React. If we need a custom hook, it's going to go in the same directory as the component that needs it. And if that hook winds up being useful and helpful and truly is a hook that has more purpose, then you can move it up a level or move it around. But we try to do that even very carefully. Incidental duplication doesn't mean that the things are actually tied together. And if you need another subcomponent within your component, that's going to go in the same directory as its parent. So we sort of fell into this pattern because that's kind of the common convention in React. And what we ended up building as we started using React is something that's far easier to reason about, far easier to change, far easier to delete as the application's needs change and grow or go away and become obsolete. And things are much easier to reason about that way. Now, I used to think of HTML, CSS, and JavaScript as three separate concerns, right? Because that's what we were taught. So what I was taught in the early to mid-2000s is that you should never mix your HTML and CSS and your JavaScript. Those are three separate concerns. But as we start thinking about use cases and what the application is providing, they become, these three technical things become separate aspects of one concern, where HTML provides the structure, CSS provides the styling, and JavaScript provides the behavior for the use case which you are designing for. They're all really one concern. I know we were taught to separate these things, but I've never, ever, ever had a case where I was able to restyle existing HTML without changing it in some form or some way. So there really is no point in that separation. We're separating along technical concerns, and it doesn't really help anything. So that's a discovery that's been happening with Tailwind and with React, not just me, although it was a revelation to me. And what I and my team discovered is that thing that Richard Gabriel called locality. And when we're building around use cases, we find that very helpful. It's a great way to think about your code. Because in React, when you need a thing and you need some behavior, and you need to process some incoming data or what have you, you're encouraged to do it right where you need it. All right, so I told you we'd get back to PHP. So let's consider, what does this mean for us? How can we think about these principles in the PHP world? What does it mean? Well, I think that what we can do is rethink how we organize our code along usage lines or along business lines and not along technical lines. How do we do that? I would like to give you a simple heuristic that has helped me tremendously in thinking about this. It still helps me. I still say this to myself as I'm designing features and systems. This is something that the predecessor leading my team championed and that I continue to champion as the leader of my team now. Now maybe you've heard of this idea that things that change together go together. Who's heard of that idea? If something changes together, it should go together. And that's very solid. And I'm just the heuristic I'm going to give you is essentially getting at that. But the question that I ask and that I think you want to ask is the thing easy to delete? Is the thing that you're working on, is the feature that you're working on, easy to delete? In other words, does it have tendrils so deep into the rest of the code base that deleting it would be a nightmare? It would be an exercise almost in futility. Now, whether you actually would delete the thing that you're adding or working on is immaterial, I would argue. It's the mental exercise that we're after. The mental exercise of can you easily delete everything in this namespace leads to better architecture and better code quality. Another way to ask the question is, what is the blast radius of the thing that we're adding to this app? I know blast radius is something Kevin, my predecessor on my team, really likes to talk about. Can I press that can I select that namespace and press delete? And what happens when I do? And so what this does is it helps you to contain the thing that you're working on as carefully as possible to the namespace that it's in. This is the co-location of related things. And then that namespace will only have one or two tendrils out into the rest of the application, into the rest of the outside world, so that something can actually use it. And then what we found on my team is that we build far more reliable, far more resilient, and easier to maintain pieces that make up the application. So, speaking of pieces of applications, you probably all remember microservices. I jest. Microservices are a good thing. They're still here. I'm sure we're all still using them to some degree. And on my team, before I was on the team, our application, one of the applications that I work on, had started to go down this microservices route. Now, in some ways, I would argue that it was perhaps split up along unhelpful lines, but that's really neither here nor there. The idea behind microservices is not bad, right? I think that sometimes those lines were drawn unhelpfully. We've split up along the wrong lines for microservices. But the idea is that we just want to abstract things and contain things into a certain place, and perhaps also there's some thinking about, you know, scaling and performance and that sort of thing. Most apps, I would argue, don't need 50 microservices. I think that's actually way too much separation. And if I can derail for just a second, you probably only need 2 or 3 larger services for most of your applications, and then you don't have to coordinate changes across, you know, 6 microservices to deploy one feature. And if you need to scale performance, there's load balancing and primary and secondary MySQL servers and all sorts of things like that. But the thinking behind microservices is worth exploring some more. What we're trying to do with microservices is not a bad thing. And one of those ideas is that when we draw boundaries properly, then you split that off into a microservice and you can co-locate the things that are related together in one place, and by nature, by necessity, you have contained them to that one place. And what I've been describing is really a way to do that within one application, not have physical different microservices, but within your application, within those namespaces, you have microservices. So this is taking the microservice mentality and applying it to the way you work on applications. What I'm trying to instill here is to draw good and helpful boundaries and make those things self-sufficient and apply it to a single project. So I want to dive into some more specifics. I don't want to leave you with just my high-level thoughts on organizing by use case. And I think by diving into some specifics, I may actually be able to drive home a little more the point of the exercise and what we're doing. So organizing by use case, as you can see, is sort of like microservices, but within one application. In the PHP world, particularly in the Composer era, we tend to store all of our the application code in a directory called source or SRC. And so what I typically do is that's where my use case boundaries go, is within the source directory. And so you'll have various use cases defined by that high-level boundary. And these can be thought of as microservices within your application. And we do need to think deeply about use cases and boundaries and dependencies. That's another important part of thinking about how these things work together. And so when organizing by use case, then you'll be able to jump into a project. Maybe you've never seen this project. Maybe you've only heard of it in some other part of your company, but then you get pulled into it. And you'll be able to comprehend it at a really high level very quickly and very easily. For the purposes of this presentation, I developed this itty-bitty little application. I only spent about a day and a half on it. It's a little to-do/note application. It's only to demonstrate co-location. That is its sole reason for existence. And this is a very small-scale application. It's just to help you get an idea of it. But even though this is just a small-scale application, I'm working on much larger applications that are built in this way, and it scales up very well. This application is not feature-rich. It lacks niceties. It's not a deployable application. I wasn't trying to do that. It's just a working demo. You can download it and run it on your computer. There will be a link at the end. And I encourage you to do that if you want to look at how I think about the things that I'm talking about today. And there are 2 main features in this application: to-dos and notes. So as we look at it, if you look at how it's organized, you can see that there are a couple of technical concerns at a high level: authorization and persistence. And that's okay. We're working in a technical space. It's okay to have technical concerns. But what I've done here is notice that I have not spread the pieces of authorization and persistence all across the app. They are contained as use cases right here in the source directory. And so when you look at this directory structure, if you wanted to make changes to the notes feature, where do you suppose you would look to do that? It's not a trick question, right? You look in the notes directory. Notes are pretty much self-contained in that notes namespace. And the tendrils into the outside world in this namespace are very limited. And I would want to point out that somewhat relatedly, those tendrils are provided to the entry points in this namespace, right? Nothing in this directory is going to reach out and do things. Dependencies are declared in the constructors, or in like for the HTTP action, you have certain dependencies in the outside world and the arguments of the method. And then you have a dependency injection container that is coordinating all that. And so you might recognize that as the inversion of control principle. That is a very important related topic that I would encourage you to explore if you haven't. But everything in this notes directory is pretty much self-contained right here. So let's explore the entry point, the HTTP entry point into this namespace. So I think you can easily see that this accepts an incoming HTTP request. We're on the outside edge of this namespace right here. This is the incoming entry point. This is the one tendril coming in from the outside world. And so we do need to know a little bit about the outside world here, and this is where we collect that information. This action, this HTTP action, collects the information, and then it's going to dispatch a request to the more inner workings of this namespace, the parts of this namespace that don't know anything about the outside world. And it's going to get back what it needs, and then it's going to pass that to a template, which it renders, and it will return that output as the response body. All of that happens within the notes use case boundary. So everything that this action now, this class is talking to, is inside that notes boundary. And at a high level, you can easily comprehend. Obviously, there's a lot more to comprehend here, but at a high level, you now know what's happening in this namespace. So what about adding a note? If you wanted to work on the feature of adding a note, where would you go in this directory structure? This is not a trick question. There's a namespace there. I've considered it sort of a sub-namespace or a sub-use case of the main use case of notes. So I've created a namespace called add. I won't go over every detail of this little demo application. You're welcome to do that on your own. I would encourage you to do that and ask me questions. It's totally fine. And even within this way of thinking, there are many different ways of thinking about things. But I think you can start to see the organizational principles at work here, instead of organizing by technical concern, but organizing by use case. And what's great about this is the intentionality of the boundaries. Very little in the notes directory depends on the outside world. If you delete the notes namespace, all you need to do at that point is remove the route that leads to it, that HTTP request that's coming into it, and then in the UI, you'd remove the tab that lets you get to it, and then it's gone. There's no other repercussions, because as I designed this namespace, I thought very carefully about how that boundary would work and function. And you may also want to delete the database table if you were to delete the notes namespace, or you could just leave it there. A lot of options there. So I'm not a mind reader, but your thoughts have been coming at me so strong that I can almost hear you asking, what about separation of concerns? Isn't that important? To which I would say yes, separation of concerns is very important. I think it's a fundamental core principle of good software design. But the question we need to ask is, what are the useful separations of concerns that drive better behavior and better software development, and what are harmful separations of concern that at best serve no purpose and at worst drive poor software design? So that's the question we really need to ask. So as we think about separation of concerns, let me present you two diagrams. This first one is the more common convention of organizing these concerns by their technical nature. And as you look at this diagram, I think you can get a sense of the meaninglessness, architecturally speaking, of the separation of concerns of the technical nature. Because at every point, we're crossing a boundary, right? The HTTP request comes into the controller, and then that goes over to the services, which goes over to the models, which goes to the database, and everything comes back, and we go to a view and get a template. And you can see that we're crossing those boundaries at every point. And so architecturally speaking, what are we doing when we're organizing this way? Boundaries mean nothing in this model. The organizational principle does not actually help us to understand our software and what the software is doing. And because we cross these boundaries all the time and we've drawn these meaningless distinctions, we can't draw meaningful distinctions. And we don't see these distinctions as boundaries, we just see them as some way that we organize. And I would argue that that is a problem. These are distinctions without a meaning. So for the second diagram, I want to instead draw the lines of communication which will reveal to us the architecture of the application. Which elements are constantly talking to each other to get their jobs done? And so this is diagramming organizing by use case. And you can see that this makes a lot more sense because everything that's talking to each other is defined within the boundary of the use case. The HTTP request comes in through that boundary, and then everything happens within the boundary. And then we send a response back from that boundary. And there are other boundaries floating out there that at the moment we don't really care that much about because we're working on this use case. And so we don't need to hold this mental model of all the various disparate parts of our application by their technical concerns. What we really care about is what the application is doing for the feature that we're working on. So draw the lines of communication, and I think you'll see a much easier way to draw boundaries. And now, when we have these meaningful boundaries, and then if we ever have to cross the boundary to do something, that should make us stop and think, should we be crossing this boundary? Is the thing that we're calling from some other boundary, is that going to change separately from this use case? And so maybe it's incidental duplication, and that's fine. So from the beginning of my presentation, I hope you remember this proposition, that we want to be better engineers. I want to be a better engineer. And so the question is, can thinking about our code this way make us better engineers? Or isn't this just technical preferences? You prefer to organize by use case. I prefer to organize by technical concern. Well, the problem is, I think I've illustrated the problem, is that it's not a good way to think about how the application flows. You know, you might be thinking, to be a better engineer, I really want you to talk about language features or better conditional logic or something like that. And those things are important to some degree. But boundaries and encapsulation, I think, are how we become much better at our jobs. I would say, in fact, that learning to draw boundaries, learning to draw good boundaries around the features of software was when I went from mid-level engineer to a senior plus engineer. You know, you've heard the adage, there are two hard things in computer science, naming things, cache invalidation, and off by one errors, right? Well, naming things is hard. It can be hard. And what is naming things? Naming things is declaring what something is and what something is not. And so what we're doing by thinking about our namespaces is we're expanding the naming of the thing beyond just that final segment of the namespace. We're saying the whole namespace is important in naming things, and that is a hard thing to do. But it's something that, in order to become better software engineers, we have to get much better at. Naming things is hard. Drawing clear boundaries is hard. And when I was a mid-level engineer, I had to go from organizing by technical concern to drawing better boundaries, because organizing by technical concern is not scalable. It doesn't encourage us to think deeply about our software and how it actually works, and it's not good for long-term stability and maintainability. Another heuristic that you can use, it's similar to the can you select the namespace and press delete, is can a non-technical person understand the boundaries by their names? Right? Whether a non-technical person is actually going to work on your code is immaterial. You're after the exercise. And by creating software that's easy to understand, by writing our source code in a way that's easy for software engineers to understand, which is the point of writing source code, we're going to become better engineers. Drawing boundaries in unhelpful places encourages thinking about things in the wrong kind of units. And they're units that don't actually make any sense to the business of the application or the real world. But drawing meaningful, more helpful boundaries, it aligns more closely with the work we're doing at any given moment of the application. It encourages encapsulation of responsibilities that actually make sense and makes features easy to maintain and easy to delete. So, if you're interested in continuing down this thought process, if anything I have said has resonated with you, I would encourage you to ask these instigating questions the next time you're working on a new feature. I've actually, we wanted to start walking down this road in a Laravel application that I work on, and it was organized along technical lines, and so we just started new namespaces for new features as we were adding them, and those can live side by side. So it may look a little bit like a mess as you make the transition, but that's a way to do it. So ask these instigating questions as you start new features. Where is the real, meaningful boundary for the thing that you're working on? Is the thing easy to delete? And can a fresh engineer walk into the project and understand the code base? Draw the lines of communication and let the architecture reveal itself to you. And I think you'll find that this will start helping you to understand software in a way you hadn't before, and it will make you a better engineer. Thank you for your time. The app that I mentioned, that's that QR code down here. You can rate my presentation and give me lots of thumbs down and boos on joined in. Does anybody have any questions?
Yeah, so there's an online question here that they say, isn't a technical concern kind of like a template use case that's at least a good place to start for when you're just starting a project and don't really have a good feel for what exactly the use case is going to be?
I would say that you're getting the cart before the horse. If the only way you can think of the feature is by its technical concern, then you don't understand the feature yet. And so you really need to think about what it is the application is going to provide. And if you don't know that, you really can't start writing the code for it yet. That would be my answer.
Cool.
So, yes?
What do you do with more interrelated use cases? Like you can attach nodes to a to-do item as well as having them on their own. What do you do in that kind of case?
I would say that notes on a to-do item are a different feature from the notes that are generally in the application. And so you might have a sub-use case. Maybe there's notes on a to-do, and so you would have something called notes in your to-do feature, but I can't see how they would be related to to-dos, at least at a very high level. That's the first thing that comes to my head. That would be incidental duplication, where you have something that looks very similar to something else in the application, but they're going to evolve differently and change differently over time. Like,
I've worked on systems where it was in fact the same thing, but you want to be able to operate on all notes. Some of them are associated with the to-do, and some are associated with the user, and so on.
so you're talking about like a relationship between notes and to-dos.
Yeah.
Yeah, it's an interesting use case. I'd have to give it some thought. I mean, architecturally speaking, there are ways that you can communicate across boundaries that still reduce the reliance on each, so that you're going to have a couple more, by necessity, you're going to have a couple more tendrils than you would in the feature that I just showed. But there are ways that you can do it, perhaps DTOs and that sort of thing to cross the boundaries. There are probably ways that you can do it, yeah. Yes?
From your perspective, what is the difference between what you just explained and a domain approach?
Very similar, or perhaps even nearly the same thing. They're just different words. Sometimes I like to use different words to talk about something so that I don't have to deal with baggage of what a word may mean to someone, because I've found in talking about domain-driven design that sometimes words mean different things than they mean to me, to different people. But it's a very similar, or even possibly the same approach. You're thinking about the features of your application. Now in domain-driven design, there are lots of technical things that you can talk about, and I wanted to avoid that because you can talk about like entities and models and these sorts of things and how you model the data. And I was wanting to be at a little more high level. So, yeah. Anyone else? Yes?
How about infrastructure pieces? Like you, in the notes example or the to-do example, you referenced the template engine. That's not part of the note system.
Yeah.
So do you also have an infrastructure segment, an infrastructure use case, or is that just a different?
Yeah, so in this case, there are, so the template engine is a good example. I actually have written a itty-bitty little, I've often wondered, like, why are we writing these elaborate template engines? PHP was started as a template engine. And so I've written just an itty-bitty little thing that just puts a little bit of dressing around PHP to actually run PHP as templates. So anyway, iComposer required that package, and I am using that in the notes boundary. So perhaps that's a little unfair because that's outside the boundary in some way. Everything has dependencies, and it's about the trade-offs of how you think about it. Yeah, so that would be an infrastructure piece. It's just like so you saw that I had the persistence director, the persistence namespace, and so even though that is its own thing on a certain level, at another level, the notes feature does have to know about persistence, and so it knows about things in the persistence directory. Yes?
Another question. Is a plugin-based, like plugin architecture, something that makes this approach feasible?
A what architecture?
A plugin-based.
Plugin?
Yes.
I'm not sure what you mean by plugin.
There are some, like, the first thing that comes to mind is WordPress, but like there are some some components for Laravel that makes possible for us to build plugins to enhance some functionalities within Laravel.
Sure.
So is that something that would make this feasible in your perspective? So for example, like we would be able to build complete functionalities in a plugin and keep, so we could.
I see what you're saying. Yeah. So sure. I mean, you could do a use case or use cases in a plugin or an add-on to your software, Laravel, or if you're working in Craft or Expression Engine or WordPress, certainly you can do that. There's nothing wrong with that. Does that answer your question?
Yeah, kind of like, is that approach something that you understand as separating by use case?
Sure. Yeah. So I've not worked much in WordPress, very little in Laravel. I do have a Laravel app that I have to work on now, but I dislike it. I know I'm in the minority, but I have worked a lot in Expression Engine and Craft CMS. I don't anymore, but I used to. And I would often write plugins or add-ons, depending on which system. One system calls them plugins, one system calls them add-ons. But you can contain features within plugins or add-ons in a way, and so you can think about that as providing a feature. Yes, that is something you can absolutely do. Anything else? Well, thank you so much for indulging me.